Hi, I'm Chris Johnson, Director of Design on the Web Platform team at ServiceNow. I get a lot of questions about how we're approaching our web-based UIs, how UI Builder, components, and theming work, and especially why we're doing what we're doing to modernize our front-end stack. So I thought to myself, such a beautiful day outside. Let's go out and record a video to answer these burning questions. Now, a lot of what I'm going to share is based on conversations with customers like you at Snugs, PAX, and at Knowledge. I also have the privilege of meeting with many customers who are pushing the envelope of what's possible and really innovating using our modern tools and capabilities. Now, my goal with this video is to start at the beginning and provide context so that you can understand the why. We'll then build on that context and go deeper at the end. Now, I can't cover everything in the video. And so we've created a companion community article that goes along with this video, which will have all the links, resources, and an update set that you can load on your own instance with the examples that I'm going to cover. I've also cut the video up into chapters so that you can hop around to the various topics. Please post any questions on that community article, especially if you have topics that you want us to go deeper on in the future. We're working on other videos and training materials. And of course, if you find this valuable, please share it. Before we go much further, I should probably introduce myself. I live in rural southeastern Wisconsin, and I've been at ServiceNow since 2019. My team is responsible for tools like UI Builder and Service Catalog, as well as our web infrastructure. I have a passion for education, and I spend a lot of my time training and teaching designers, PMs, engineers, and our sales team more about our wonderful web platform. I've been writing HTML and CSS for more than 25 years now, and I love building useful applications that help people work better. All right, as Bill says, let's go! ServiceNow is a platform built for flexibility. One of the reasons that you trust and deploy ServiceNow is because you can make it work well for your businesses. More than 20 years ago, Fred Luddy built a product for IT departments called GlideSoft, creating solutions for managing tickets, support, operations, and assets at companies. It wasn't until 2006 that we changed our name to ServiceNow. We continue to innovate with our technology workflow products. But we aren't just an IT company anymore. We make products for HR, customer service, finance, and the employee experience. Our workflows and tools span across many departments. This unification on top of a single platform is a key part of the reason we've been successful. ServiceNow sits at a unique and central point in your businesses because we integrate with so many of the systems that make your organization function.
Well, as I've been saying for a long time, the enterprise has shifted from on-premise to cloud. It has shifted from point solutions to platforms. As you know, ServiceNow is the end-to-end platform for digital transformation.
In this video, we're focusing on web experiences, and we ship roughly 3 types. Let's talk about each. The first is what I like to call our OG UI. Now, this goes by many names like Classic Platform, Lists and Forms, UI 16, or officially as Core UI. For much of ServiceNow's history, this was the only UI. If you needed a new laptop from IT, you created a request in ServiceNow, and the agent on the other end would fulfill that request in the same UI. This is practical, but it's clearly optimized for the fulfiller, not the requester. Over the years, we've introduced other interfaces that could be better tailored and weren't as complex. First with UI pages, and eventually with AngularJS Service Portal, which I'm going to refer to as Portal for the rest of this video. You have created a vast assortment of different portals for many different use cases. But in very simplistic terms, ServiceNow has created portals to serve 2 groups, employees and customers. Portals are designed to be much more visual than core UI. They're designed to align to your company's brand and visual style fitting seamlessly into your overall branded experiences. You're probably familiar with the Now Support Portal, which is an example of this from ServiceNow. And we know that more than 90% of you are leveraging portals in some form or another. But these portal UIs are built on an older technology with some technical disadvantages, which is why our third web experience exists. We call this modern web framework the Next Experience UI framework, and internally we refer to it as Seismic. Workspaces and many of the tools, builders, and admin interfaces that you use to build, configure, and customize an instance are built with the Next Experience UI framework. We'll go into more detail about these three interfaces a bit later. ServiceNow is an incredibly flexible platform and has been since the early days when Fred started the company. This power and flexibility have enabled us to take what was built in support of IT and technology workflows and apply the ServiceNow platform to new and different use cases across departments like customer service, employee, HR, and finance and procurement. One of the things that most surprised me when I joined the company in 2019 was the idea of giving you, our customers, the same set of tools that we use to build our products internally. You can sort of think of this as no cheating. Did you know, for example, that our internal developers use UI Builder to build their workspaces? There isn't special secret stuff that we use internally. You have access to the same capabilities and functionality that we use to build our products. I gotta say, I found this openness pretty refreshing. You have access to the same platform capabilities that we use, and in a lot of cases, you configure them without writing any code. ServiceNow has been low-code since our initial founding. The platform is powerful, flexible, and approachable to a wide array of users with different technical knowledge. And you're able to leverage this low-code platform to create applications in a fraction of the time it would take to write the same thing in code. At ServiceNow, you hear the word platform a lot. We are the AI platform for business transformation, after all. But what does that platform word mean? Because let's be honest, it gets used a lot. When we talk about the ServiceNow platform, everything we do, every product, every feature, every service is built on the singular ServiceNow platform. That means that once you learn the platform in one context or product, you can leverage that platform knowledge to other products and features without needing to learn something new. It's powerful stuff. And we're serious about this. When we acquire a new company, we don't just bolt it onto ServiceNow. No, we take the time to rebuild and re-platform so that when the capability is available to you, our customers, it's built on our platform and fully integrated. This single platform mindset is core to everything we do and the decisions that we make. For this discussion, we're focusing on building web experiences on ServiceNow. Today, our web experiences are built using a hodgepodge of different technologies. For example, customizing core UI form view is done using Apache Jelly. No, not that Jelly. No, the Jelly that I'm talking about is an XML templating language that supports HTML and dynamic capabilities. Jelly enables users to show different UI depending on a piece of data, like if a record was open or closed or high priority. Jelly is used to render most of the core UI. Jelly has served ServiceNow well, but no one would ever accuse Jelly of being modern. Jelly is old and has many limitations. When new UI capabilities were needed, ServiceNow front-end teams adopted other front-end frameworks to power experiences that weren't possible in Jelly. Portals use AngularJS, others use Bootstrap, and some UIs use React. But let's be honest, this is not an ideal way to approach our web front ends. In an ideal world, we would all benefit from standardization and unification so that we can implement something once and reuse it everywhere. Moving forward, the new experiences and features we build are all on top of the Next UI framework. And this standardization has already brought increased speed for our development teams, more consistency to our user interfaces, and the ability to leverage the modern benefits that this framework brings. The next Experience UI framework is our modern front-end framework, and our new product experiences are built on top of it. This new framework is built by ServiceNow for ServiceNow, unlike Jelly, React, or AngularJS. It is also built leveraging modern web standards, namely the Web Components API. Now, if you aren't familiar with Web Components, they're a set of JavaScript APIs and capabilities built into all modern web browsers to enable the creation of reusable and encapsulated HTML components. Because Web Components are native to the browser, they bring certain performance benefits not present with some other proprietary frameworks. Here are some basics about Web Components. First, Web Components are encapsulated using the shadow DOM. What that means is that the CSS, HTML, and JavaScript inside the component are shielded from the rest of the page. Other libraries can't inject content into the component, and styles don't escape out of the component onto the rest of the page or into the component from the page. Second, Web Components use custom HTML elements, which are fully featured DOM elements that are built in a standards-compliant manner. To illustrate what I mean by this, we can look at the standard button component in our UI framework. When we look at the source code of the page that uses this button, we can see that the DOM element name for the button is now-button, and it has several ServiceNow-specific attributes that are used by the page. There's a lot more about Web Components to learn, and if you're interested in more information, take a look at the MDN Web Docs articles for Web Components, as well as our developer documentation that covers the ServiceNow specifics, links in the community article for this video. The ServiceNow library of components are standards compliant, but they are proprietary and built by ServiceNow. Some of our components are available in GitHub, and as of the Washington, D.C. release, we have more than 150 components available in UI Builder. Many of these components are documented on our Horizon Design System site, horizon.servicenow.com, with usage guidelines, API information, and links to the files in Figma. With every platform release, more components are added, and the library of components is constantly improving. In addition, when you install ServiceNow apps from the store or enable our products, additional components can become available. One of the questions I get asked a lot is how components are different from Angular widgets. And it is true that there are some conceptual similarities between them. Let's take a moment to understand them, as components are different in some key ways. Both components and widgets enable UI reuse. In both, you have a component or widget library and assemble a page with these pieces. But, and this is a big difference from the world of Service Portal, we don't expect you to clone a component, and we don't allow you to do so. This, combined with the fact that web components are truly encapsulated and don't allow for code or style injection, are a major departure from the world of Service Portal. And this decision is purposeful. When you clone an Angular widget, you're separating that widget from its author, and you become the owner of that code. This means you're responsible for maintaining and managing that widget going forward. You won't receive any improvements, updates, enhancements, or security fixes that the original widget author might make over time. This can get quite time-consuming to manage. What's more, if you look at the Service Portal ecosystem, there are thousands of widgets, and many of them do very similar things. This can cause confusion, and it can increase development costs. And finally, both our Jelly-based UIs and Angular-based portals are often customized by direct DOM manipulation of the elements on the page. Now, this can make it quite challenging for ServiceNow product teams to improve or change the products without breaking your customer implementation. The Next Experience framework and our adoption of web components is an attempt to address these issues and many others by setting up a better foundation on which to build for the future. Let's go inside and dig into the components in more detail. Think of a component like a Lego block. We have a library of components, and these components can be assembled together to create the different products and features on our platform. When you buy a box of Legos, you get a bunch of different pieces in that box that you can assemble in lots of different ways. Some of the components we've created, they're extremely generic, meant to be used in lots of different contexts, just like this 4x2 brick. The heading, button, and input components are examples of general purpose components. Some components, though, are more specialized or complex, designed for specific applications, similar to this Lego window from my son's helicopter set. These components are created and maintained by ServiceNow platform or business unit teams, often by the product teams that require them in their products. But in general, we're striving to create components that can be reused in many different contexts so that we get all the benefits of efficiency. Component building teams at ServiceNow look at not only how it might be used in a specific context or a single product, but how that component can be made into a general purpose tool that can solve a variety of problems in many different experiences. The very first product that we released on top of our new UI framework was Agent Workspace. And so sometimes there's confusion that our Horizon design system and component library are only about workspaces, but that is not the case. Our components are not designed for a particular experience or UI, but are meant to be used all over. For example, UI Builder uses the exact same buttons as Catalog Builder and CSM Workspace. The Next Experience Unified Navigation Framework is also built with these same components, as are dozens of other UIs that we've released. We take our platform responsibility seriously, and we approach the components that we build through that lens. Components are often made up of other components. For example, the activity stream component uses headings, icons, buttons, and a dozen other components assembled together into a functional unit that displays the activity on a particular record. Almost all our components are made up of other components. Components have configuration API, and this configuration changes how the component works or how it looks. A component API is a contract, and we maintain backwards compatibility for our component APIs, even as we upgrade and improve the component itself. To support interactivity, many components also emit events. Events like configuration have an API, and many events also have a payload with data that is provided each time an event fires. Like many other reactive programming implementations, our framework leverages a props down, events up architecture. To learn more about this and related concepts, I've added links to cover that in more detail to the community article that companions this video. ServiceNow builds components to a high standard. In addition to ensuring that we maintain API backwards compatibility, our components are WCAG compliant, work with our internationalization and translation infrastructure, and will display correctly when themed. Our component library is large and continues to grow. But if you want to build something that is unique to your business, you can build your own components using your favorite IDE and our command line interface. And at the end of the process, your components will show up in UI Builder just like our components. Check out the companion article for more information about that too. So now that we understand the differences between components and widgets, the capabilities of our components, and how we build them, let's explore experiences and how the modern experiences differ from the past. But in order to do that, we first need to talk about metadata. Let's head outside and get into more detail. When a new designer joins my team, one of the most important things that I want them to understand is the concept of metadata and how it impacts what we do at ServiceNow. ServiceNow has been a low-code platform since the very beginning, and a key reason why is because so much of the platform's capabilities are built on top of and configured through metadata, not code. But it's probably a good idea to start with a definition. Metadata is structured data that describes other data. Let's illustrate this with an example from my childhood, and that will date me. When I was growing up, I would go to the library at school to find a book about a particular topic. My school library didn't have a computer, but it did have a card catalog. The card catalog was a shelf with drawers full of index cards that were organized by author, subject, or title. If I wanted to learn about birds, I would go to the card catalog, open the subject drawer and find the cards for each of the books that had the subject of birds. This is metadata. Author, title, subject, and location in the library are all structured data that describes the particular book. At ServiceNow, we use metadata everywhere. We use it to describe the data that is stored in the ServiceNow database. We use it to describe the UIs that we use to interact with that data, like a list or a form. We use it to describe the rules about the data, like who can edit it or what type of data is allowed, and hundreds of other examples. Metadata is a part of the abstraction layer on top of the complex code and systems that ServiceNow engineering teams have built. It's the metadata that allows you to configure an instance without writing code. I'll give you another example. Imagine that you wanted to create a simple web page from scratch with a form that saves data into a database. In order to do that, you'd need HTML and CSS to display the form, JavaScript to set the behavior of fields, and finally code that takes the user inputs and stores it in the database. This code is probably written in a programming language like Java, PHP, or server-side JavaScript. We would need some SQL to save it in the database. If the form is complex, and if you want only valid data or only certain people to be able to submit it, a large amount of complex code and integrations are needed to deliver that experience. But the same form experience when built on ServiceNow, powered by metadata, can be built in a fraction of the time. It is very straightforward to create a table to store data, configure the rules for that data, like which fields are mandatory, set data types, and configure the security and access control rules without requiring any Java, HTML, CSS, and SQL. It's all because we've built this abstraction layer on top of a large amount of complex software. When a ServiceNow form is rendered in a web browser, what's really happening behind the scenes is a form is being constructed from metadata records. There's metadata that describes all the form views that exist for a table. There's metadata that describes the individual fields on that form view and what should happen depending on their state. There's metadata that governs who should see what fields and who has access to certain data. There's even an individual record for each choice in a choice field. What that means is even a simple ServiceNow form grabs metadata from more than 10 tables in order to render in the browser. The power of the platform is that you have access to all that metadata, and you can configure it to serve the needs of your organization. Core UI is an example of a metadata-driven UI. You don't need to write code to get these forms and lists to work. As you make changes to the metadata, the UI changes automatically because it is reading the metadata and then transforming it to a web page. Sometimes, when the metadata gets complex, we add additional layers of abstraction that help you create or configure the metadata. These tools, often called builders or designers, guide a user through the process of building something, while behind the scenes, they're just creating a lot of metadata. Form Designer, Mobile Studio, Process Automation Designer, and UI Builder are all examples of this. When Service Portal was released, it moved away from this approach for much of the UI and instead relied on AngularJS code that would be written by a developer. Through research, we know that ServiceNow administrators can be frustrated or intimidated by this Service Portal code. There can be a fear that making changes to it could break your portal. Service Portal UIs have a much more customizable and visually rich user interface, but they lost the low-code approachability of Core UI. With our new web platform, we're trying to get the best of both worlds. Visually rich UIs that are backed by metadata, not code. Our product teams can create components with code if they need to, so can you, by the way, but those components are configured through metadata records. It's metadata all the way. As you can imagine, the metadata required to power a visually rich experience like a workspace is complicated. Let's peel back the curtain and explore this metadata in more detail. Let's put our hard hats on and dive into two important concepts, experiences and macroponents. I think it's always important to put safety gear on when we're before diving into the metadata records. An experience is the user interface of a particular part or workflow of an application. Workspaces and portals are two common experience types, but there are others. Our modern web platform is not limited to these two types, and we have many builders, tools, and admin interfaces that are built on the framework that aren't either one. For example, UI Builder itself is built on top of this framework. Experiences live in the Sys UX page registry table and under the Now Experience Framework module in the All menu. Experiences share a set of common elements. Each experience lives at a URL, and those URLs exist after /now/ on your instance. When a user goes to the URL for an experience, they are served a default page, which we often call the landing page. An experience is a collection of one or more pages. Each of these pages is accessible by its own URL, and the URL is a child of the experience's root URL. An experience has an app shell UI, which is the common UI elements that are present on every page. You could think of it as the app Chrome or app wrapper. The app shell defines the frame where the pages inside an experience render. The app shell UI is present on every page in an experience. When you create a new experience, you select the app shell you want to use. Today, some app shell configuration is done in UI Builder, but much of it happens in core UI records. Each app shell has specific configuration, depending on which app shell you choose. But app shells are about more than UI. Behind the scenes, the app shell is also responsible for the loader, login, logout UI, help, search configuration, and other features that live across the entire experience. Let's apply this to a basic workspace example. In this example, our workspace lives at the /agent URL. When a user navigates to that URL, they're shown the default page of the experience. For many workspaces, that lives at /home. Often, that page is a dashboard or other analytics content. Most workspaces also have a list page at /list and a record page at /record. And the Workspace App Shell UI has a vertical list of customizable icons along the left side of the screen. It also has tabs or breadcrumbs for wayfinding through the experience. Our product teams add additional pages to their workspace experiences to meet their product requirements, often replacing the default pages with entirely new ones that are more optimized for a particular use case. In the San Diego release, we launched Unified Nav, known externally as the Next Experience UI and internally codenamed Polaris. We'll discuss this in more detail in a bit, but unified navigation leverages a new type of app shell that is called a parent app shell. Parent app shells wrap multiple experiences. When an experience is inside a parent app shell, the parent app shell takes over certain functionality. For example, search moves out of the workspace and to live inside of Unified Nav, as well as help, user profile, and Now Assist. Theming is also handled by the parent app shell. So if you have a theme set for an experience that is different from the parent app's theme wins. All of this is powered by the Next Experience UI framework. We've talked about experiences. Now let's step down one level and focus on a specific type of metadata. This metadata is created and edited in UI Builder, and it has a funny name, the Macroponent. Macroponents are a metadata record in the SysUX Macroponent table on an instance. Now, normally, I would try to avoid talking about jargon and words like macroponent. But in this case, I need to make an exception for a few reasons. Macroponents are a general-purpose UI record that are so flexible, they're used for many parts of our modern experience. Macroponents are used to store page composition, but also for components, controllers, viewports, modals, modeless dialogues, etc. So they're all over the place. The term macroponent also shows up across many of the UI framework tables and fields. So if you're looking at records in Core UI, you're going to see it. Let's open up a Macroponent record and learn more about the structure of this record. Pro tip, you can do this from UI Builder using the Developer Open Page Definition menu. If you want to follow along at home, you can find the update sets for the example experience I'm using in this video, linked to in the community article. Now, I don't know about you, but I'm not a huge fan of writing complex blobs of JSON. UI Builder is the tool that is used to do this work most of the time, but I think it's important to understand how all this stuff works. So we're going to be digging into the Macroponent, but I would never suggest creating or editing a Macroponent in Core UI. It's just much easier to do in UI Builder. The easiest way to think about a Macroponent is that it's the metadata ingredients that will be used to assemble the final web page that is sent to a user's browser. These ingredients include components and their configuration, layout, data, events, and the various relationships that exist between all of the ingredients on the page. Because the content is stored in a structured format, UI Builder knows how to read and write it. Macroponents are made up of 4 key fields: layout, composition, events, and data. Macroponents can also have state parameters, configuration properties, and client scripts. I'm working on a Xanadu instance, so it's possible your Macroponent record might look a little different than mine. Let's start at the top. The first main field is layout. This field defines the overall Macroponent structure and rules for how elements render. When you change the styles for the body or root element in UI Builder, your changes will impact the layout field. Over the years, we have iterated on our layout model to support enhanced capabilities, with the most recent update to support responsive design. The version of the layout model that this particular Macroponent uses is at the end of the field, in this case, version 3.1.0. The next field is the composition field, and that, as you might guess, is where the components and their configuration live. It's the composition. Let's look at this simple demo page to illustrate this point better. This simple page has a heading component, a button component, and an image component. The button, when clicked, will open a modal which has a picture of one of my chickens. All these page elements will be inside the composition field, as will the configured values for each component on the page. I find that a good way to understand this better is to create a page in UI Builder, add some components, configure them, and then go to the Macroponent to understand the metadata that drives the configuration. In this case, if we look at the metadata for the heading component, we can see that the label is stored here in the JSON. If we change the values in the Macroponent to something like a beautiful day in the neighborhood and refresh the page, we will see the new text show up in UI Builder or in runtime. Components have configuration, which is basically their API, and the values of that configuration are stored in the composition field of the Macroponent. So every configuration that you see in UI Builder will have corresponding data in the Macroponent record. But it isn't just the configuration. Styling and events will be added here too. Let's take a look at the button, which is configured to open a modal. When we look at the Macroponent record, we can see that the button click event is mapped to open the modal. Event mappings can get complex, and we'll talk a bit more about how they work later, but just by looking at this data, we can see that the button's button clicked event is communicating with the app shell to open this modal using a relay event mapping. Relay events will relay or pass the event from the page Macroponent to its parent. The app shell itself is responsible for opening and closing modals and app navigation. So events like this must be passed to the app shell. Events are powerful things, and I've included some additional resources and links in the community article for this video. The final important field of the Macroponent that we're going to cover is data. The data field holds the list of data resources on the page and their configuration value. Data resources are conceptually similar to components in that they both have configuration properties, basically an API, and events. But unlike components, they have no UI. Instead, data resources output data based on how they're configured. The data output can be leveraged on your page in a variety of ways, but let's start with a simple example. If we add a lookup a single record data source to the page and configure it to grab a record from the task table, what is happening behind the scenes is a glide query is fetching a single record from the database with whatever field metadata that you configure. In this simple example, I've configured it to return the sysid, number, short description, active, and assigned to fields. When the configuration of a data resource changes, the output updates automatically. I can then use this data output in a variety of ways on my page, and we'll go into more detail about how to leverage data through data binding in UI Builder later. But before we open UIB, I want to briefly touch on one more part of the Macroponent, and that is client scripts. In the early days of the Macroponent, client scripts were stored in the Macroponent record like layout, composition, and data. But now, client scripts live in a separate record on sysux client script table. And you can see all of the client scripts for a particular Macroponent in the related list at the bottom of the Macroponent. Let's switch gears and move from looking at the record data in UI Builder so that we can better understand how all this comes together. We don't need hard hats anymore. UI Builder, which launched in Quebec, is our UI configuration and authoring tool for building on top of our new framework. UI Builder is the tool we use internally to build ServiceNow products, and it is the tool that you use to configure and customize these products. UI Builder and the framework that it's built on continue to receive a lot of investment from ServiceNow, and we have accelerated this development more recently by moving UI Builder to the ServiceNow store, which increases the number of releases that we can make per year. UI Builder is a low-code tool, and you can use it to customize and build on top of the products you pay for from ServiceNow, such as the Service Operations Workspace or Customer Support Workspace. But it can also be used to build custom application UI. Open UI Builder by typing, you guessed it, UI Builder into the All menu. Remember, I recorded this on a Xanadu instance, so you might see something a little bit different depending on what version you're using. When you open UI Builder, it starts by showing you an inventory of all of the elements that it can edit. You'll see a list of experiences, page collections, and in the future, other types of UI. It also presents useful help content, tutorial videos, and other getting started content. Who knows? Maybe this video will show up there someday. Let's choose the demo experience, which you installed with the update set from the resource for this video. When we open the experience, we're presented with a screen we've nicknamed Experience View. This is a listing of all of the pages and variants in the experience, as well as links to edit and configure each. Speaking of pages and variants, we should define those. Pages contain one or more page variants, and this concept is conceptually similar in some ways to how a form view works for a table. A page is a name, and it has a URL path, and pages can have required or optional parameters. These parameters show up in the URL, and we'll talk more about them shortly. When someone navigates to a URL in an experience, they're going to a page, but the variant is the actual UI that is shown. While there is more than one record behind the scenes that makes all this work, I think it's easiest to connect the variant to the Macroponent record. Variants are targeted to criteria to determine which variant is shown. For example, many of our workspaces ship with multiple record page variants that target specific tables so that you might see a different record page for records in the user table versus the incident table. When creating a variant, you determine the criteria and order, and this logic will determine which variant gets shown. The most specific variants should have the lowest order value, and the most general should have the highest order value. You can target pages to user criteria using audiences, and this can be very powerful. But I don't have time to cover this topic in this video. I've included some more information about audiences on the resource community page for this video. Remember when I mentioned earlier that pages can have both optional and required parameters? Let's unpack that by using the standard workspace record page as an example. The workspace record page comes with two required parameters, table and sysid. We call them required because if you don't provide them, nothing will load and you'll get a 404. You can define any number of required parameters for a page, but all page variants use the parameters that are defined at the page level. So, all record page variants in a workspace would require both table and sysid. But the record page also ships with a few optional parameters, and like their name implies, they're optional. You can navigate to a record page with some or none of the optional parameters defined, and the page will still load. The record page ships with 4 optional parameters: query, extra params, views, and selected tabs. These optional parameters can be used to support additional page functionality. For example, when you navigate from one tab to another on the record page, you'll notice that the optional parameter for selected tab changes. And this allows a user to copy the link, send it to someone else, and the recipient will see the same tab that you were looking at. Required parameters are always listed first in the URL, and the order of these parameters matters. Optional parameters are added to the end of the URL after the /params, and because they have both a label and a value, they're order agnostic. There's another important thing to understand about required parameters. If you ever add or remove a required parameter later, you'll need to update any links that point to that page and ensure that they include all the required parameters, or users will see a 404. Now that we understand the experience, let's open up a page and explore the UIB editor. The UIB editor is structured with 3 primary regions: inventory, stage, and configuration. The page inventory shows a content tree with all of the containers and components on the page, and it is roughly equivalent to the DOM. Below this listing of components are all the data resources, client scripts, and client state parameters. Components can be selected by clicking on them directly on stage, where the page is previewed, or from the content tree. Once an object is selected, the specific configuration UI appears on the right side in the configuration panel for the selected object. Component configuration is divided into 3 tabs: config, styles, and events. We discussed the connection between a component's API and the configuration experience in UI Builder when we covered components earlier. To learn more about how each component works, go to our Horizon Design System website, which includes documentation and guidance for many of the components that are available in UI Builder. Let's click on the Styles tab. Styles control the visual configuration of layout and CSS, but keep in mind that much of the visual presentation for our components is set by the theme. For example, if you want to change the background color of a button, you cannot do this in UI Builder because that color comes from the theme, and it will change automatically when the theme changes. Instead, these and many other visual properties for a component can be configured in Theme Builder. Install Theme Builder from the ServiceNow store to more easily create, edit, and manage the theme record on an instance. In UI Builder, the Styles tab controls the CSS around a component, as well as the CSS that governs page layout. UIB relies heavily on modern CSS capabilities like Flexbox and Grid. If you aren't familiar with them, I would suggest reading the great content and tutorials you can find on MDN or in many other places linked in the resources article. But when it comes to page layout, I can do some basic overview of these 2 concepts. For simple pages, I start with our basic column layouts because they're really easy to configure without needing to know CSS, and they have basic stacking and responsive behavior built in. These basic layouts support up to 6 columns, and UI Builder has included a set of common column layouts that you can then customize. I also like the fact that columns allow me to easily change how many I have later. So if I start with 2 and then need 3, it's as easy as clicking a single button. You can place layouts within layouts. UI Builder is very flexible in this regard. For more complex page layouts, you can add a Flexbox or Grid container to the page, which are actually just the same thing, just configured to use one or the other to start. I generally use Flexbox for most of the pages that I build, as it is simpler to configure and designed for layouts in a horizontal or vertical direction. The blank page in UI Builder is a Flexbox in the vertical or columns direction. But when I'm using a repeater with a variable data set from the database, I use Grid. Grid is a two-dimensional layout system that adjusts automatically when you give it more or less data, which is why it is perfect to pair with a repeater. Let's illustrate this with a simple card example. Let's say I want to query the incident table and get back all of the items that are assigned to the currently logged in user or group of users. This information is highly variable. It could be as low as 0 and much higher, potentially into dozens of incidents. And potentially it could grow even larger than that in a large organization. So the one-dimensional Flexbox layout system is not ideally suited for this use case. In this case, I want to define a card layout that is up to 5 cards wide and will grow to as many rows to support up to 20 records per page before using a pagination component to move between larger sets of data. All I need to do is set up the grid with 5 columns and 1 row, a set of minimum and maximum widths if I want to be responsive, and everything works. The browser automatically adds more rows to the grid as needed, and it can grow to very large sizes of thousands of rows and columns in those cases. Grids are a bit more complex to configure because they're quite powerful, but for a variable set of data, they are really useful due to their built-in flexibility. Let's move on to the Events Configuration tab. Not all components have events. Events can be pretty simple and straightforward, for example, when a user clicks on a button, but events can also fire at other points in time, like when data is successfully loaded or when it fails to load. Some components have many events. By default, events don't do anything, so you need to connect an event with an event handler that will do something with that event. We call this connection event mapping. For example, let's imagine that we want this button to open a URL to ServiceNow.com when clicked. The button clicked event would be bound to the link to destination event handler. Events are the glue that connect all the various interactions in the UI together. Page navigation, displaying a modal or popover, triggering a client script, changing or setting a client state parameter, and displaying a loading animation are just examples of the event handlers that can be bound to an event. A single event can have multiple event handlers. Data resources, which we'll cover momentarily, can also add event handlers to your page. So don't be surprised if you see more or less depending on the page you're looking at. In addition to component and data resource events, UI Builder pages can also use lifecycle events like Macroponent ready or Macroponent property changed. Check out the resources page for more information about these events. We designed UI Builder's UI to be familiar and leverage patterns with other WYSIWYG UI building and web development tools. But unlike more simple tools, UI Builder places a much stronger emphasis on data. UI Builder isn't building static web pages or marketing sites. Nope, it's building complex web applications that you can use to run your organizations. Let's explore data and data resources next. Web applications are dynamic and data-driven. After all, the workflows, processes, and integrations that you require are complex. As we've already discussed, Macroponent records contain composition and data. Making data available to an application is done by adding data resources to your pages. Data resources are similar to components in a lot of ways because they get added to the Macroponent with very similar JSON, have configuration, events, and are meant to be reused. Data resources can be used to query data that is located on a ServiceNow instance through Glide or a custom GraphQL query. They can be used to transform data so that it matches a certain format. Data resources can also read and write data. The app shall provide some data to the pages inside it automatically, like user or session data, the user's name, roles, local time zone, preferences, etc. Data resources are built by teams across ServiceNow and, like components, are available in UI Builder. And, just like components, you can build your own. Complex pages can have many data resources on them, forming a web of relationships between components, data, state, and page scripts. To encapsulate this content and simplify this, resulting in a better user experience and improve the upgradability of pages built on the framework, we added a new data resource type called a controller in the Tokyo release. Think of a controller as a kind of folder that contains the data, business logic, and state information required to drive a complex page or use case for a part of a page. Controllers can contain any amount of data resources, client scripts, and client state parameters. But in UI Builder, the controller hides all of that stuff inside of it from the person using UI Builder, and instead provides a single configuration UI with a single output. When we move the standard workspace record page to this new controller paradigm, we reduce the number of user visible items in the data panel from more than 20 down to 1. And that record page controller provides the data via its output API that all the components on the record page use. ServiceNow built controllers have an API contract, so they maintain backwards compatibility. And because the internals of the controller are hidden, controller authors are able to change and improve them without user visible impact. Controllers are closely connected to presets, which we'll cover shortly. But before we do, I want to talk more about leveraging the data on your page through data binding. ServiceNow is a workflow company, and I'm pretty sure you're not building simple, static websites on the platform, but instead, complex, workflow-driven applications tied to data. This data can come from a variety of sources. And the cool thing about the way that we've built our components is that they don't really care. This is a design principle for how we approach component development. You can pipe data in from anywhere. And as long as it's in the correct format, the component can use it. The way that a component is connected to a data source is called data binding. When you add a component to a page, it comes with sample data to help a user understand how it works and what it looks like. For example, the heading component has the default label, "We make work better for people with modern digital workflows." But you can change that label to whatever you want. Most of the time, you want your components to use data, not static values. On the workspace record page, the heading at the top of the page is bound to the short description of the record. So when you look at a new record, the heading text changes automatically. When you log into an instance and a page greets you by name, for example, "Hi, Chris," the heading component is grabbing your first name from the session data and concatenating it with the string hi, comma, space using a function. You'll see your name, I see my name. Same component, same configuration, different data. Any configuration property on any component or data resource in UI Builder can be bound to data. Whether that property is a string, Boolean, choice, reference, array, complex object, well, you get the idea. And it isn't just components. Event mapping, scripts, and client state parameters can use this data binding too. If we return to the workspace record page example that we talked about in the previous section, and we look at the controller output, we begin to see that the controller's job is bringing in the data that the components on the record page need in order to function. There's a lot of data, and the components connect to it via data binding. Data binding uses a .walk-like syntax as an address to a particular part of the output. Think of this kind of like a URL to a particular part of the data. For example, the address for the short description in the record controller is @data.record.form.header.primary item.display_value. That's a bit of a mouthful, but there's a lot of data that the components on a record page need. We don't expect you to type all this out though, which is why we have a data UI that visually navigates the output and allows you to easily drag and drop data pills for data binding. And this UI supports functions like concatenate that I mentioned earlier, which is useful because in many cases, you don't need to write script, you can just use the function. To switch an input property from a static value to a data binding, hover over the configuration property and click the database icon. This is also the method to write a script, which can be useful in certain more complex cases where functions aren't enough. The product experiences that ServiceNow creates are meant to be configured and customized. But these products are also upgraded and improved over time. You want to get these improvements while retaining your customizations and configurations. So let's unpack the concepts of upgradability a bit more, especially presets and controllers. As we explore upgradability, let's start with components because they're the easiest to understand. One of the advantages of our new front-end framework versus, for example, AngularJS is that when you use components from ServiceNow, you get upgrades and improvements to those components automatically with no changes required by you. You'll always be using the latest version of the button, form, list, heading, or the more than 150 other components that come with UI Builder. We ensure that component APIs are supported through an API contract. Our standard set of components are a part of the platform family release, so they will be upgraded automatically when you upgrade your instance to the next family version. Other components are part of plugins or store apps, but the only difference with them is that they may get updated more frequently. If you build custom components, when you change them, any pages that use those components will get the changes you make automatically also. So it's important to be mindful of changes to your component API to ensure that your changes don't break pages that are using that component. Controllers are similar to components from an upgradability perspective. ServiceNow built controllers maintain an API contract to ensure that changes don't break pages that leverage them, and any changes to a controller apply automatically to every page that uses that controller upon upgrade. Controllers, which were not originally a part of UI Builder, were designed to support very important upgradability for our pages by encapsulating data fetching, business logic, and state inside an upgradable object. You may have noticed that the word preset appearing at the top of the component configuration panel. Presets are the method for encapsulating configuration of a component or controller in an upgradable manner and to speed up page building. They do this by enabling automatic configuration of components and data resources. Let's take a look at presets in more detail now. Presets were added as a part of the Tokyo release, and their use has expanded to include many ServiceNow created pages. Presets are a set of configurations for a given use case, and they connect a component to a controller. Let's use the heading short description from earlier as an example to understand this better. It's common to use the heading component to display the primary field, often the short description, and there is a preset for this use case. This is the same preset that is used on the Workspace record page for the heading at the top of that page. We discussed this earlier. Select the heading component and choose the record title preset. When you do this, the preset is going to set all the configuration properties that are required to display the primary field by binding it to data. Since the page that we're using has no controllers on it, this preset will add a form controller and guide us through the setup required for that controller. The form controller is how we're querying the short description from the database. The form controller defaults to use required URL parameters to get its table and sysid. And just like that, I have a heading component that has been configured to display the primary field for the record. A controller has been added, and it has also been configured with a preset. But the cool thing about presets is that they understand context. Watch what happens if I add a form to this page. The form component will automatically configure itself to display the form for this record coming from the record controller. If I add the action bar component, it will automatically be configured to display the actions for this particular record. I've basically built a very simple record page in a very short period of time. As of Xanadu, presets can configure controllers in addition to components. Several of our more complex components can also bundle additional components onto the page. In this case, a viewport modal was added as well as a popover that are required to show reference field content. I don't go into detail about viewports or bundles in this video, but I've included some additional detail on that on the resources community article for this video. Presets are upgradable in the same way that controllers and components are upgradable. When a preset is upgraded, any component or controller that is using a preset will get those changes automatically. But presets have an important additional benefit: overrides. For example, let's say that I would prefer my heading text to be a bit smaller. Right now, this heading is configured to use the header primary style, but I want to use the title primary instead. I could remove the preset, but if I do that, I won't get any of the upgrades that the preset author at ServiceNow might ship, and I have to manually configure all that data binding. Instead, I'm going to override a single prop that is set by the preset to my own value. So I hover over the configuration that I want to change and click to override. Once I do this, I can set the value to whatever I want. I could pick a static value, which is what I'm going to do in this case, but I could also use data binding or scripting if I choose. What does this mean for upgrades? Well, all the other properties on the heading component are still controlled by the preset, and I've only taken responsibility for that one configuration of that header style property. So I will continue to get upgrades and enhancements from the preset, but my overrides will be maintained from one family release to the next to the next. Preset overrides are stored in the Macroponent record you're editing. So you'll only be able to override the pages that you can edit. Well, that was a lot of information, and I hope you found it valuable. I mentioned this at the start, but one of the best parts of my job is getting to see what you all have built on the ServiceNow platform. I'm blown away by the way that you take these pieces and put them together in new and interesting ways. Keep it up, and we'll keep pushing the envelope and making the platform better. Please take a look at the community article for this video. Leave comments, questions, or requests for additional content there. And if you know someone who would benefit from this, please share it with them. Also, I'm going to include links to the User Experience SIG, Special Interest Group, on the community, which is a hub of great content for delivering great user experiences on the platform. If you're interested in learning how to do that, please go check that out. And finally, we need your help. We need more people from the community to sign up to participate in user research studies. My team and the design teams across the organization rely on users like you to help drive the future of our products, and we need more people to sign up. So I've included a link to that as well. All right, well, it's getting kind of late. I think it's time for me to go feed some chickens. See you later. Bye-bye.